Thanks everyone for having me. So, yeah, as Bruce was saying, I'd like to share a few comments and thoughts about how a group actually came together from a very diverse set of backgrounds and experiences, and how that was actually the key into creating this kind of new innovative technology here in Canada, in Toronto. So, and as an example of the diversity, or as an example of how different perspectives actually could put this together, I'll start with myself. So, just quick introduction. That's where I actually come from, this small mountain town in Italy. It's very cold in the winter, and it rains a lot in the summer. So video games and computers, excellent. Very, very good choice right away in the beginning. So, and so much so that I actually started my career back when video games actually looked like this. So some of you actually may remember some of that past. It turns out actually after our career in this, I liked the concept of actually making tools for these games, tools for people who actually made media and games. So I did move to Toronto. This was actually back in the early 2000s. So I joined this company, Alias Wavefront, downtown Toronto. So, and I started actually working on real-time visualization, large-scale computer graphics at this other company called Silicon Graphics that at the time actually were joined at the hip. And then after a few years of this, I liked the thought of having as much performance as possible in computers. So that actually was kind of the trait, kind of the linked all of my steps. I ended up here, actually, where I had a chance to actually work on the largest computers that you can actually get your hands on, and that was actually pretty interesting fun. So after a while actually working on this, though, the CTO of Autodesk, Jeff Kowalski, called me as a friend of a friend and asked me to have an interview with me or to have a conversation, because something was actually happening to Autodesk business that was actually going to change the world, or change actually the way that business was actually being operated. And was this, right? So the cloud actually was coming and was trying to disrupting entirely the business. The competition was Adobe at the time, well, still is, and others, right? So they were successfully transitioning toward a subscription model. And so Jeff was actually really kind of desperate, or interested in creating something that was not Web 2.0. And some of you still remember actually those words perhaps. So, but something that actually didn't have to do with just social, that just had sharing or storage, right? So, but it was actually something that we could monetize, or that they could monetize on the cloud, but that would kind of disrupt the competition. So I was skeptical. Again, the cloud is a very different type of environment than the very deterministic supercomputers that actually I had worked on. But I remember him actually showing me that picture here, and then telling me something about, these aren't the droids you're looking for, or something like that, right? So, and I turned out actually at Autodesk, actually, it's kind of fuzzy, right? So for a while, I actually worked on these. I just kind of went back to my familiar items, so large-scale, computational numerical analysis and computation, especially optimization and physics. And this actually was okay for a while. So as in, we essentially rented out computational time for customers to use, to actually have a better understanding of their designs. Autodesk makes computer engineering software, computer-aided design tools, right? So this was actually an accelerant for some of our customers to actually get their products to market somewhat faster, or actually with better validation, etc. But at some point, roaming around conferences in manufacturing, I'm not a manufacturing engineer whatsoever. I'm like pure computer scientist, right? So visiting some conferences, I actually ended up looking at this thing, or the equivalent actually back then. So this is a multi-material 3D printer. So with this, myself and my colleagues actually suddenly actually started talking from non-engineers with very different types of backgrounds. And we quickly realized that if you have the freedom to put any material you want, anywhere you want in a given volume, then all of a sudden, our collective kind of limited brain power could not decide where to put what to do something, right? So to create a bracket or a shoe or a jet engine, the volume is the same. You just change the materials and where you put it, and voila, it's a different design, right? So, but how do you decide? How do you decide actually where you put what, right? So it dawned on us that there was actually quite a bit of a problem in the industry that we were serving, which is actually that computer design, design is a lie. So, or at least it has been, including the products that we sell ourselves, actually, or at least so far, haven't been really computer-aided design as such. But really, they are an extension of this. So this is the very, very early prototype from Mr. Sutherland, actually, that created the first kind of sketch drawing system on that computer, which is much, much larger than this is in the pictures. Right? But the problematic challenge that we still face is that these tools are documentation tools. Like most design tools, they are just there to report your documentation. You have to invent everything yourself. You have to think about your solutions to your problems, and then you use these kind of glorified drawing boards to express them. Right? But there's no aid in the design whatsoever. Right? So that's actually a challenge. So what this brings is this, right? This is bias. And I'm sure you're familiar with all this, right? So bias actually in design means that people have all sorts of effects that are related to their education, their expertise, their environment, their backgrounds, right? So, and diversity in your team actually can mitigate actually some of this, right? So, and you reach actually different design or different solutions for your problems or for your customers' problems based on the composition of your teams, right? So we decided to do some of that, but also something else. This is an example of bias, right? So it's clearly something that a computer would say is perfectly reasonable, perhaps, but none of us would ever use as a solution. Right? So we kind of tried to change the game. Again, we come from different perspectives altogether. Some of us were like physicists, some of us were computer scientists, people from, again, video games, of all things, right? Or other things, or other fields, other paths of life, right? So we got together and then we said, okay, let's just reframe this and change the problem of computer-aided design from documentation to searching, right? So to creating a new set of tools that express the problem solving as a search problem, right? So we came up actually with something like this, with an iterative kind of workflow or path where you express your problem to the computer. You don't express the solution, right? So, and that's a very kind of big kind of paradigm shift. And this is where we lost Autodesk. As in, like people actually thought we were nuts, you guys came from Mars, or at least very bipolar, right? So in a large organization like Autodesk that has been around 40 years, right? So this type of entrepreneurship is hard to come by. It's kind of not easy to come by, right? So growing it that required, creating an MVP that was just extraordinarily good, right? So Autodesk is known for acquisitions and kind of rarely for kind of growing its own internal innovation, right? So convincing a large organization like this to make a bet on this was actually pretty tough, right? So, but it turned out to be successful. So, and that's why I'm here to relate to that. So these are actually the four kind of main stages. You define the problem, then the system actually goes away, generates a bunch of solutions. You explore the space of the solutions that it gives you, and then refine, and then you iterate the definition of the problem and your tweaks, and then you decide to actually build your output, right? So just a crude example, but if you wanted to design, say, a frame for a quadcopter, you would literally input the phrase quadcopter frame. The system comes up with a template of where the various parts actually need to be located, the load, so the physics that actually are behind it, the steps that are actually needed to collect all the required electronics, etc. Right? So what are the objectives? It needs to fly, so it needs to be pretty light, it needs to be stiff, to actually to not fall apart, right, or to break actually on the wind, etc. And what materials you want to actually make it with, etc. And then we apply a hefty dosage of this, right? Which is the cheap, abundant computational resources that are in the cloud that allows you to do all sorts of physics simulation and artificial intelligence. We'll explain. And all this, again, with the addition of our friend machine learning that is allowing us to actually reduce the time it takes, both to capture the designer's intent, but also to compute the various solutions. and then the machines actually produce solutions, right? This is actually kind of a very kind of quick example of the visualization of, let's say, kind of how some of these algorithms think, if you will, right? So they just move material around, they try different things, and they play it in a simulated world, of course, right? In a virtual environment, right? So where they compare and contrast all these potential shapes in this case, actually, and then they come up with a variety of options for you to choose. But where a standard kind of regular design team, as amazing as it could be, it could come up with, I don't know, 4 or 5 different options in a given amount of time. This thing can actually churn out, thousands, like in hours, right? So, and the purpose is not just to replace your design team. That's just actually the point, is to supercharge the design team, right? So all these options grow the ability of that team to think or to see things that they hadn't seen before, right? So you actually evaluate, the trade-offs actually between them, and then you actually choose the one that you want, and then, you just build and fly, right? So you just add the electronics and actually go. This is just to say that products can be designed or created actually in a very different way, right? So and this could actually apply to your industry verticals too. So this is another example of where we closed the loop on creating products that actually engage into kind of feedback, kind of creative feedback, where the sensing, which is part of the IoT that I'm sure you're familiar with, the Internet of Things, actually can drive directly evolutions of the products themselves, right? So this is also true for, again, some of your industries. So in this case, actually, we wanted to quickly create a chassis for a car that was actually meant to actually be raced on a racetrack. So we started actually, it was actually a small garage in California, actually, that wanted to do this project. Very creative, but with kind of regular engineering talent, like a very small pool of guys, expert in pipe welding, and that's it, right? Just creating these very simple structures. So we started by scanning one of their prototypes, which was very rude, very over-engineered, very quick. And then we instrumented it, we tested it, and we generated a new solution, and then we iterated, right? We cycled the loop. We essentially read the performance from the sensors, and then we iterated. So, we equipped the original mule chassis with sensors, and then we ran it like crazy, actually, on the racetrack to simulate in real life the performance, essentially, in the physics, essentially, the amount of stress that the real car actually would then experience, but using this engineering prototype, if you will. So, and then the system went away, and that actually made essentially a new chassis, actually based on the real-world data that we collected. And this, some of the process. I mean, these guys actually are from Hollywood, so they know how to make a nice video. Right? This is definitely not me, not at all. I'm like the console guy back in the dark room. And this is the output, right? So they actually managed. So the system actually managed to create a chassis made of pipes, and essentially it instructed CNC pipe bending and cutting machines to automatically produce all the pipes and the map of the pipes. They were shipped in a box, actually, to the garage. They had the map. They assembled the chassis, and it was done. Right? So, and it was like substantially lighter and stronger than anything they had ever designed before, and it took hours to build. Right? So, just the last example, right? So, of eating our own dog food, and this is actually where, again, Toronto actually came into prominence again. Is recently we moved offices from an excellent neighborhood to an even more excellent neighborhood. Right? So we moved recently to the Mars building, which is here downtown, and we had the problem of deciding how to create our layout, how our spaces, our offices. Right? So what we did is that we ran surveys. We ran a survey of all of our employees to understand what do you prefer, where do you prefer to work, and what actually makes it more fun, more productive for you to work here, right? So would you like to actually sit across from your friend? Do you like space? Do you like light? Do you not like light? Do you like silence? Do you like, kind of more productive? Do you more adaptability, etc. Right? So, and then we ran all this actually into our system. It created, again, thousands upon thousands of possibilities, and then distilled all the choices actually into one. And here you can actually see pictures of the actual office, which, again, if you're ever here in Toronto, you're more than welcome to come and see, because that's literally where we sit. So we thought, if we cannot live it ourselves, that we cannot ask our customers to ever, buy into this thing. Right? So this is an example, well, the audio.
Known as 3D printing. One of those ways is generative design. It really takes inputs of design constraints, load requirements, keep out zones where material can't be, and it generates thousands of different design solutions working with the software that maybe a single designer, engineer couldn't come up with on their own. It's an expansion of our current capabilities, really focused on how are we going into the future with lightweighting, with new manufacturing process, thinking about designing and making our vehicles in a different way. Autodesk is one of our valued partners that we see as we go forward in the additive manufacturing space, really helping us from a thinking differently, the innovation culture that they can bring to us, as well as some of the tools that they have for design for additive manufacturing. One of the first parts we worked on in collaboration with Autodesk was a common rear seat bracket. This bracket consists of 8 pieces, welded together, bolted together. We worked very hard to consolidate that part into one piece, something that can only be produced using additive manufacturing. We ended up saving 40% mass, and again, got that part consolidation from 8 parts down to 1.
The benefit is really to be able to explore the design space in a much more efficient way than you can using a traditional approach.
We get multiple designs within a short amount of time, which is a feasible solution to our problem, which would probably take a normal engineer weeks to figure that out.
GM has traditionally always been a leading innovator in the industry, and it's great to see them adopting these new technologies and seeing how it applies to their business and to their customers.
We feel that there's huge benefits today, but then those benefits can really ramp up as we move into the future. Really, the opportunities for GM around additive manufacturing are endless.
Okay, so how cool does this look? 5 years ago, we were, nutcases, right? So that's what I'm saying. So to reach this, it took a lot of convincing, even, within Autodesk, within our ranks, right? So we had like completely bipolar approaches, bipolar judgments of this work, right? So, but what I wanted to say is that this actually took a large concerted effort. So it started extremely small. It started a very, very, very small group of people. But the diversity of backgrounds, the diversity of opinions managed to kind of push this through, right? So, and to actually make it reach a stage where the leadership just couldn't ignore it, right? So it was actually kind of too interesting, too disruptive to fail, potentially, right? So, but it wouldn't have been possible if we didn't assemble actually the right people. And I actually recruited most of the team actually here in Toronto myself, and I found that, again, Toronto is just a phenomenal community that where, again, I could source from people of all ethnicity, all backgrounds, genders, everything. So, and this is really kind of what powered this to success, as in, like, without it, we just couldn't have done it, right? So just to say, just a quick takeaway, maybe, think about, hire a physicist in your team, or hire someone who in his background, his CV, has something unusual. Like, just hire people with different perspectives on things, because the innovation, or at least in my career, my expertise, innovation really comes from melding minds between people that have very different perspectives, right? So that's all. Thank you.
Thanks, Francesco.